Hello and welcome to the series of video lectures on operating system. In the previous lecture, we started with the disk scheduling algorithms and we learnt about three different disk scheduling algorithms. One is FCFS, second one is SSTF, shortest seek time first, and the third one is scan algorithm. And we also noted down how many cylinders are traversed in each cases. Now we will move on to the next scheduling algorithm called as C-scan or circular scan. Here it provides a more uniform wait time than scan. The head moves from one end of the disk to the other, servicing requests as it goes, like what scan does, but it is doing in a different way this time. So when it reaches the other end, however, it immediately returns to the beginning of the disk without servicing any request on the return trip. So treat the cylinders as a circular list that wraps around from the last cylinder to the first one. Okay, so in this case we will learn with that example here. See, the C scan, the same set of queue. Okay, scheduling queue is given and the head starts at 53. Current head position is at 53 cylinder. If you see, as scan moves from to the left end of the disk, now your C scan, circular scan, moves to the right of the disk. So right side, it services first 65th cylinder request, then 67th, then 98, then 122, then 124, then 183. Eventually, if you see, there is no request after 183 till 199. Because for our example, we have considered the total number of cylinders from 0 to 199. But from the given request queue, there is no service request from 184th cylinder to 199. But what happened, the circular scan, it goes to the right end of the disk. Like what scan does. Scan moves to the left. So if you see, after 14, there is no request from 0 to 13 cylinder. But it goes to the left. Similarly, from 184 to 199, if there is no request also, it moves to the right end of the disk and then it again goes to the left end of the disk. So if you see the difference here, when it goes to the left end of the disk, it merely goes without servicing any requests. So that is why we say that C scan is a circular scan. It treats a circular path. Okay, so it treats the cylinders as a circular list. Okay, so it goes to the left end of the disk, that is the 0th cylinder, and then it comes to the right for servicing 14th request and then 37th cylinder request. Now what is that? We need to note down the exact cylinders traverse while taking into account this entire traversal from the right end to the left end, that is total 200 disk traversals, cylinders traversal should be taken into account for the traversal. Okay, right? So that is the case of C scan. Then C look. So what is the C look? Look is a version of scan. Okay, so before going to the C look, we will learn about look. So look is a version of scan algorithm, already we learned, and C look is a version of C scan. Okay, so what is that? Arm only goes as far as last request in each direction, then reverses direction immediately without first going all the way to the end of the disk. Very simple. So we will go back to the scan algorithm here. If you see here, now I'm going to explain for look. Okay, right? So arm goes from 53 to 37, 37 to 14. In case of look, it will not go to the beginning of the disk. It will service 14 and return back to 65, 67, 98, 122, 124 and 183. So this is the corresponding implementation for look. Okay, look is another version of scan. Only difference is it will not go to the beginning of the disk. So whichever the corresponding request, that is in our example 14th cylinder request, up to that it will go to the left side and it immediately switches to the right side of that direction and it will service the remaining request. So this is about the look. Similarly, if you see here, C look, it is similar to C scan, but what will happen? It will move to the right of the disk, servicing 65, 67, 98, 122, 124, 183. Okay, after 183, it will not go to the end of the disk, right end of the disk. it will go to the left end of the disk as usual. Okay, so only from 184 to 199 it will not traverse. See, look. So it will, after servicing 183, immediately it goes to the left end of the disk, that is beginning of the disk, and then continues to the right hand side for servicing 14 and 37. So this is the implementation of look and see look. See here. So whatever I have explained with that previous slide, so it goes to the right and services 183, gets back to 14. Okay, so eventually it does not goes to 0 also. So it comes up to the 14th request, which is the waiting in the queue, and then it is servicing the 37 by returning to the right hand side 37. So actually I made a mistake in the explanation previously. It does not go to the beginning of the disk. So up to 14th request only it comes, and then immediately switches back to the right hand side. So this is called as C look. Now in what case with which we will select a disk scheduling algorithm. So SSTF is commonly and naturally is used because a number of drivers disk cylinders will be lesser, and the scan and C scan perform better for systems that place a very load on the disk. So it is used because of less starvation. Performance depends on number of types of requests. So depending upon the types of requests. So request for disk service can be influenced by the file allocation method. So that is the most influential factor here. The disk scheduling algorithm should be written as a separate module of the operating system, allowing it to be replaced with a different algorithm if necessary. Because if you write as a separate module, depending upon the usage and the scenario, the algorithm can be modified. Either SSTF or look is reasonable choice for the default algorithm. So that is the case. Disk management is corresponding to low-level formatting or physical formatting. So where the dividing a disk into sectors that the disk controller can read and write. Each sector can hold header information plus data plus error correction code (ECC). Usually 512 bytes of data but can be selectable. Okay. To use a disk to hold files, the operating system still needs to record its own data structure on the disk. So partition is the disk into one or more groups of cylinders, each treated as a logical disk, and we call it as logical formatting or making a file system. To increase efficiency, most file system group blocks into clusters, disk IO done in blocks and file IO done in the clusters. Raw disk access for applications that want to their own block management, keep OS operating system out of the way. Boot block initializes the system. The bootstrap is stored in ROM, that is read-only memory. Bootstrap loader program stored in boot blocks of boot partition. So methods such as sector sparing used to handle the bad blocks. So thank you for listening the lecture. We will continue the lecture for further topics. Thank you.